Hey everyone, welcome back. In this video, I'm going to explain the starting system circuit, and this video is going to be specifically for the starting system. We already have some other videos on the channel for a starting system diagnostic or a starting system circuit inspection and analysis, but this one is different from those videos. If you have no cranking situation or you are doing diagnostic on a starting system circuit, this is going to be very helpful. We're going to go step by step by looking at the wiring diagram first to understand the starting system circuit on this car, which is a Ford Fiesta 2010, by the way. And of course, we're going to do the diagnostic on the car as well. For that part that we are doing the diagnostic on the car, we're going to use Vdiag V500 Pro circuit tester, which is going to be very helpful for diagnosing any circuit. So before starting the video, if you guys haven't subscribed the channel yet, please don't forget to subscribe. If you are interested to learn more about starting system diagnostic or other systems diagnostic, we have many online courses that you can find the link in the video description. So what you see is one page of the wiring diagram for a starting system for this Ford Fiesta that we have today. I know that many of you are gonna ask me where to find the wiring diagrams. I have mentioned this one before. There are many websites out there selling the wiring diagrams. Whatever we have in PDF format are available on our website that you can download for free, including this wiring diagram and many others. They are on our website. You can go there, you can download all of them for free. You don't need to pay anything. So a starting system on this car comes in 2 pages. So at the very beginning, I'm gonna identify the components on the wiring diagram. Then we go for checking how a starting system works when we actually try to crank the engine. That's very important for doing the diagnostic. For performing the diagnostic, the first step is to understand how that system works. Then we can start the diagnostic. So let's have a look at the components first. At the first page of the wiring diagram, right here, you see the ignition switch. We have the central junction box here providing the power supply to the ignition switch. This component at the center is powertrain control module or engine control module. We have transmission control module here, because it's very important for starting system to monitor the transmission at the time of the cranking. That's why we can see the transmission control module right here for the car with automatic transmission, and this one is clutch pedal position switch if car has manual transmission. As you see, we have some references from here to the second page that is shown in here. On the second page, we have the battery junction box or engine fuse box that I'm going to show you in a second. A starter relay is located inside the engine fuse box. We have the powertrain control module again here that I will explain why we need this one here again. A starter motor assembly is shown here as well, and high current battery junction box for providing the high current battery voltage to start a motor when cranking is actually happening. So I mentioned the battery junction box before going for actually reading the diagram. Let's have a look at the location of starter relay and battery junction box. So here is the battery junction box, and this one is the starter relay that we can take it out. I'm going to explain everything about the starter relay, how to test it as well. As I mentioned at the beginning, in this video we're going to use a special circuit tester which is from Vdiag V500 Pro. This is the main tester itself, and here we have the short circuit open circuit tracker with a couple of other probes that we can use in different circumstances. As you see, we have the lights at the front side, and this is the main probe. This tester is capable of doing many other things for us, like on the probe we have the smart tester, we have the resistance multimeter, we have the oscilloscope as well. So this is what you're going to see on the oscilloscope. I will use the oscilloscope in some other videos, not today. And if we go back to the main page, as you see, we have 0 to 5 volts voltage output that we can use for testing different components. We can test the relays that we're going to try today. This function is very helpful for testing 5 pins or 4 pin relays. This is very helpful for a starting system diagnostic. We can also test the injectors using this tester. So we already identified the components on this page. So for reading any wiring diagram, the first point is to find a starting point for that system operation, and a starting point for this system is, of course, the ignition switch. So the moment that you turn the ignition switch to start position to this one, power supply from here is going to travel all the way to powertrain control module. Right after that, ECM knows that you are trying to crank the engine, but it's very important for ECM to monitor the transmission position first. If your car has automatic transmission, ECM is going to communicate with transmission control module to see what is the situation of transmission right now. If transmission is on park or neutral, PCM will proceed for activating the starter relay. Otherwise, if transmission is on drive or reverse, engine is not gonna crank. In case that you have manual transmission, this is gonna happen by monitoring the clutch pedal position switch, which is mounted on the top of the clutch pedal. If everything is okay, if transmission is on the park or neutral, PCM will proceed for activating the starter relay. As you see, this is for activating the starter relay, and A refers to the second page that we have right here. So the rest of what we saw on the first page is going to come over here. We already know that the starter relay is located inside the engine fuse box. The power supply is already provided. We need the ground, which is going to be provided by PCM again from here. So by the time that positive and negative are provided on a starter relay, a starter is going to get magnetized. This magnetic field will close the switch inside the relay just like this. So then power supply from this F element 30 amp fuse is going to travel all the way through the starter relay, and it goes to reach to the starter motor itself. Because the starter motor receives the ground from the body, is gonna get activated, and that's it. Inside the starter motor, you see two coils that we call them pulling coil and holding coil. For diagnosing these two, we have one specific video. You can find the video in the video description. On that video, I explained how to diagnose the pulling and holding coils. But right now that we know all these, how can we proceed for diagnostic? So you remember that I explained the moment that you turn the ignition switch to start position, power supply is going to travel all the way from here to reach to the PCM. So it means if PCM does not receive the power supply, engine is not going to crank. So this 15 amp fuse inside the central junction box is very important. If this one is blown, you cannot crank the engine anymore. For making sure if PCM is receiving the signal from the ignition switch, we need to check this wire. So on this wire, you see the connector code right here, C175B. This is the connector code. On this ECM, we have actually 3 connectors. This is the relevant connector in this case. And this number down here is the pin number. Sometimes the color of the wire is important as well. You see this diagram already shows you the color, but the color code is shown here as well, just in case if the diagram that you are looking at is in black and white. So this one is in blue and white wire. After that, as I mentioned, PCM will monitor the situation of the transmission. Then it provides the power supply from here to the starter relay through this wire. It means the moment that you are trying to crank the engine, you should have battery voltage in here. And this can be tested on the fuse box. So we need to remove the relay, find this pin right here, and check the power supply over there to make sure we have battery voltage in here. For finding this one, as you see on this relay, we have 4 pins. Pin number 1 and 2, which normally called 85 and 86 on many other relays, are for the coil side of the relay. And pin number 3 and 5, which normally called 30 and 87 on other relays, they are for the switch side of the relay. When you take the relay out of the fuse box, you can actually find these numbers. By finding any of those numbers, you can locate each pin on the fuse box. So we're going to go for checking the power supply on pin number 1 of the fuse box when we are starting the car. So here is how we can do it on the car. This is the relay. If you look at the relay right here, down here, this is pin number 1. You can read it on the relay as well. So I'm going to use the tester. I insert the tester right here on pin number 1. As you see, tester is connected, and right now I'm turning the ignition switch to start position. As you see, we have 12 volts. This is actually very helpful for isolating the problem area, because if I have this 12 volt, it means PCM has received the signal from ignition switch, so I don't need to go for testing the ignition switch, and PCM is providing the power supply on the relay. It means basically everything we saw on the first page is working based on this fact. This is actually for increasing the speed on diagnostic. We don't need to go for testing each component one by one. We can go point by point. And the main point here is to check this pin number 1 to see if problem is on the first page of the diagram or on the second page. If you do have power supply on pin number 1, it means everything on the first page is working properly. You need to focus on the page 2 of the diagram, which is the starter relay and everything else that I'm going to explain right now. As you see right now, I'm using this circuit tester. It's reading the power supply. This is not the only thing this tester is doing. I explained it at the very beginning, and I'm going to try to make more videos using this tester. As I mentioned earlier, when this starter relay is activated, it's going to close the switch, and battery voltage from this F1130 amp fuse is going to travel all the way through the relay to reach the starter motor. For testing the switch inside the relay, we're going to test the relay very shortly. I'm going to show you how to test the relay with the circuit tester that I have today, but checking the circuit before this is very important as well. So for testing the voltage in here, if you look at this point, you see that voltage should be present all the time, because this fuse is hot at all times. It means the voltage here is provided all the time. You don't need to crank the engine to read the voltage. So again, you need to take the relay out, find the pin number 3 based on the numbers that we have right now on this car, and read the voltage on the switch side of the relay. Let's see how we can do it on the car. So basically, again, I'm going to go for the multimeter, and using this prop, relay is removed. This time I'm going to go for pin number 3, which is on the switch side, and I should have the battery voltage reading right now. If battery voltage reading is provided, it means anything on that side of the circuit, that fuse and the circuit between the fuse and the relay, they are all good. If you are not reading the battery voltage in here, you need to go for checking that side of the circuit. Of course, there are some circumstances that we're gonna need to check the relay. So let's go to the next step to see how we can test the relay with the circuit tester. If a starting circuit is okay, problem could be only from the starter relay. So if there's any identical relay inside the fuse box, you can just throw up the relays and check the starting system. If engine cranks after using the other relay, for sure it means that a starter relay itself was bad. But there are some circumstances that we don't have any identical relay. So knowing how to test the relay is quite important. We have a video on the channel for testing any different type of relays. You can find a link to that video in the video description. But generally inside this 4-pin relay, we have, of course, 4 pins. 2 of them, which are these 2, are connected to the coil side of the relay. And these 2 are connected to the switch side of the relay. Generally, each one of these pins are numbered. Pin number 85 and 86 are on the coil side of the relay, and pin number 30 and 87 are on the switch side of the relay. On some micro relays which come in smaller sizes, you see the numbers are different. For example, here on the coil side of the relay, instead of having 85 and 86, I have number 1 and number 2. I'm not sure if you can see it. Number 2 is written down there, and here is number 1. And for the switch side of the relay, instead of having 30 and 87, I have number 3 and number 5. That I'm pretty sure you saw it on the wiring diagram as well. So basically, by providing the positive and negative on the coil side of the relay, there should be some electromagnetic field generated to close the switch. because this switch is normally open. So you can basically provide the battery voltage to these two terminals. After that, you should hear a clicking sound. That clicking sound comes from the switch because the electromagnet is going to close the switch. For making sure that the switch itself provides the continuity, when coil is energized and switch is closed, you can check the continuity between these two as well. The good thing is on the circuit tester that we have today, we have a section for testing the relay as well. So it means I can go to this option, and as you see, I can test the 4-pin and 5-pin relays. For testing the relays, I'm going to use another cable that I have in this kit. So I'm going to attach it just like this. And these three should be connected in a specific order. So right here, I have the manual as well. So if I click on OK, I have the guide for connecting the cables for a 5-pin relay. And if I go to the next, this is for a 4-pin relay. So I don't need to connect the green. Black and red on here should be connected to pin number 30 and 87, which on this relay are pin number 3 and 5. So it's going to be like this. And I need to connect the auxiliary ground clips on 86. And right now, if I go to the previous page right here, as you see, if I press the up button, I'm gonna start the test and I can read the voltage over here. This voltage that I read from here is actually the output on the switch side of the relay. And at the same time, I should be hearing the clicking sound of the relay as well. So I'm gonna touch this one right now. So when I'm touching the last pin, I should press up. So I hear the clicking sound, and as you see, the voltage output from the relay was 12. So this confirms that relay is working properly with no issues. If relay does not pass the test, we have to replace the relay in this case. Alright guys, thank you very much for watching. I hope you enjoyed the video. As I mentioned, there are many videos on the channel for diagnosing the electrical circuit, using the diagrams, using different type of circuits. For this tool that I used today, if you are interested, you can find the link in the video description. And if you are interested to learn more, please do not forget to check our online courses, and the link to those online courses are provided in the video description as well. Thank you very much for watching.